In the network industry, software-defined networking, or SDN, is a buzzword that everyone has heard of nowadays, but it's hard to define. And so it's easy to become overwhelmed when you're new to SDN and you want to transform your network to become SDN enabled for the first time. Many vendors claim to be SDN, but they're only doing an automation layer over a traditional BGP network. So how can you distinguish between that and a real SDN platform with control and data plane separation? Well, one question you should always ask yourself is, how does the system handle path calculation? We can look at the example of a video game. In this game, you can see the units traveling from one side of the map to the other. In doing so, they must navigate through fixed obstacles like the bridges and moving obstacles like the enemy units. So what is path calculation exactly? Path calculation is the way that the traffic flows from the source to the destination. In traditional networks, there are routing algorithms like ISIS and OSPF. These algorithms take into account the congestion and latency, which determines the link cost. The costs are used to calculate the shortest path across the network. And so, if traditional algorithms can do it just fine, why does SDN matter? Well, for business applications, there are more factors to consider than just congestion and latency. There are also high-level business requirements. For example, your customer might have different types of traffic like video gaming and database backup with very different service requirements. You want to separate different applications into their own paths, even if the source and the destination are the same. Another scenario, your network infrastructure is separated into primary and backup links, and you want to keep your traffic away from your backup until there is an issue with your primary link. These scenarios are very difficult to automate in a traditional BGP network. But with SDN, they are easy to solve because the separation of the control plane from the data plane offers us three huge features related to path calculation. Number one, the control plane has a bird's eye view of the whole network topology. So path calculation becomes a matter of finding the right path finding algorithm. For example, algorithms such as A* and Dijkstra's algorithm can be used for path calculation. Number two, we can do even better using SDN. We can match traffic on any criteria and calculate separate paths for different types of applications like video games and voice chat. Using Dijkstra's algorithm, we can use that to calculate the K shortest path and separate traffic into different classes like gold, silver, and bronze, of which gold would have the highest priority and the lowest latency. The third advantage of SDN is we can further extend the idea of K shortest paths for fast failover into a backup path. If one of the links in the calculated path goes down for any reason, normally we will have to recalculate the path account for that missing link and then send the command to all the devices into the network. But if we can pre-calculate multiple paths, we will be able to immediately fail over to another working path. To ensure that a single failure does not break multiple paths, we make sure to calculate the K shortest path with limited overlap so that the paths that we calculate do not overlap with each other. Now you know why path calculation is a huge advantage for SDN over traditional networks. SDN is more than just network automation. It is a completely new way of looking at the network and controlling it. If you liked this video, please hit the subscribe button, and for more information, check out our website in the link below.